Assalamu alaikum. Hope all of you are fine, and I hope all of you are staying indoors, staying safe. Basically, we had done in last few lectures, so we had completed estimation frequency algorithm. We also done computation of DFT using FFT. Now we are going to do some solved examples in estimation frequency FFT algorithm. So let's start with a very basic example. So let me write it down. The example. The question is to find 4-point DFT of a sequence x of n. This is equivalent to 2, 1, 4, 3 using decimation frequency FFT algorithm, right? So if we look at this example, then the capital N is 4 here, right? So we will be using radix 2 DIF algorithm, right? So capital N is 4, we will be using radix 2, so it means the smallest decimation will be 2 point. So now since x of n, since it is a decimation frequency algorithm, then in that case we know that the input is in normal order and output in bit reversed. Fine. So input is in normal order and output is in bit reversed order. So basically, since we have only 4 input samples, so that will be from x of 0, x of 1, x of 2, and x of 3. So this so index goes from 0, 1, 2, and 3. So we have basically 4 numbers, and the 4 numbers we can represent as 2-bit binary pattern. So we have to bit reverse them. We have to bit reverse 0 to 3. So I guess so the output pattern will be capital X. So 2-bit pattern will be 0, 0. So reverse of 0, 0 is again 0, 0. So that's x of 0. X of 1, I can write it as 0, 1, and its reverse is 1, 0, and that is 2. So the reverse of this will be x of 2. Similarly, reverse of this will be x of 1, and reverse of this will be again x of 3y, because 3 I can write as 1, 1, and its reverse is also 1, 1. So this is the basic structure of the butterfly diagram that you will be using here. So basically we'll be having first the 4-point DFTs, then followed by the 2-point DFTs. In case of DITs, we have 2-point DFTs followed by the 4-point. Since we are using decimation frequency algorithm, so we'll be having 4-point DFTs. So in 4-point DFTs, the negative, the odd part is always multiplied by -1. So we'll have -1 here, we'll have -1 here, we'll be having summations here, summations here, summations here, and summations here. Fine. So our inputs are 2, 1, 4, and 3. Fine. So let's go to this first. So this is 2 plus 4. Fine. So this is 6. Fine. Similarly here it is 1, 1 plus 3. So that is 4. Fine. And here it is 4 minus 2. So it will be 2. Fine. And then here we have 3, 1 minus 3. So it is -2. Right? -2. So, and on the lower side, on the odd part, we have multiplication by total factor. So we'll be having multiplication by W40 here and multiplication by W41 here. So this term will become so this will be 2 again. Sorry, it is minus 2 here. Why? It's 2 minus 4. And similarly here it is this 1 minus 3 is again minus 2. So this will be again minus 2 here, and this is W41. W41 is W40 if we draw the graph here. So this is W40, this is W41. So W41 is, I guess it is minus J. So it is minus J. So it is this. So I will get minus 2 into minus J. That will become 2J. Fine. So this, the input here will be 2J. So I have 6 here input, 4 here input, then I have minus 2 here input, and then we have 2J here input. So again we will be having minus 1 here, we will be having minus 1 here. Right. So 6 here as input, 4 here as input, then we have minus 2 here input, and here we have 2J. So okay, so this is a summation here. Fine. So a simple summation between 4 and 6, so we'll get 10. Right. So then we have 6 minus 4, so we'll get 2. And then we have here we have a summation. We have summation everywhere. So again here we have a summation. So it will be minus 2 plus 2J. So it will be minus 2 plus 2J, and finally this 2J will be multiplied by minus 1, so it will be minus 2J. So it will be minus 2 minus 2J. Fine. So again another summation here, minus 2 minus 2J. So we have got our output. X of 0 is 10, X of 1 is minus 2 plus 2J, X of 2 is 2, and X of 3 is minus 2 minus 2J. So I will go to the next page. So I write X of k will be equivalent to X of 0. X of 0 is 10, then X of 1 is minus 2. So just X of 1 is minus 2 plus 2J, then X of 2 is 2, and X of 3 is minus 2 minus 2J. So this is our answer. Right. So now let us go to the next example. So let's do one example from DIT. So it says an example here. It says compute DFT of a square wave sequence given as x of n is equivalent to 1 for 0 is less than equivalent to small n is less than equivalent to capital N by 2 minus 1, and minus 1 for n by 2 is less than equivalent to n is less than equivalent to n minus n, and it's given n is given. So doing this using decimation and time algorithm. Fine. So what we need to calculate, so x of k, right? So also second thing which is given here is n we need to calculate x of k. N is given as even, right? But the value of n is not given, so we may take it any value. We can take it 2, 4. Let me take n as 4, so it's assumed to be 4. It's fine. So I can write x of n as, if capital N is 4, then x of n will be, therefore x of n will be, it is 0 for n is less than equivalent to n by 2 minus 1. So 4 by 2 minus 1. 4 by 2 is 2. 2 minus 1 is 1. So I can write x of n as 1 for 0 is less than equivalent to n is less than equivalent to n by 2. n by 2 is 4 by 2 is 2. 2 minus 1 is 1. And minus 1 for n by 2. n by 2 is 2. Less than equivalent to n is less than equivalent to n. Capital N is 4. So I'll take x of n. We'll take only 4 samples. So the x of 0 is 1. Fine. X of 1 is also 1. X of 2 is minus 1. Also x of 3 is within these limits, so it's again minus 1. Fine. So our sequence will be x of 0 is 1, x of 1 is also 1. I have written 1 here. This is x of 0, this is x of 1, this is x of 2, and this is finally x of 3. X of 0 when n is equal to 0 is 1. X of 1 when n is equal to 1 is again 1. X of 2 when n is equal to 2 is minus 1. X of 3 when n is within these limits 2 to 4 is again minus 1. Fine. So now we need to find x of k. That's we need to find 4-point DFT of x of n as x of k. So we will take, let's take radix to DFT. Fine. FFT rather. Radix to FFT. So we can use either decimation frequency algorithm or decimation. Let's use, in previous example we used DIF. Let's use using DIT. Fine. So let me draw the waveform. Okay. So this is the basic structure of the the butterfly diagram for 4-point DFT. Radix to FFT using DIT is decimation time. Also we know in DIT the multiplication by divisional factor is before the butterfly, in case of the or before the summation, whereas in case of the DIF it is after the summation. And in case of DIT we have 2-point DFTs first, then followed by 4-point, then 8-point, so on and so forth. Whereas in case of DIF we have 8-point first, then 4-point first, then 2nd point, so on and so forth. Fine. So we'll start with 2-point DFTs here. So and we have multiplication by divisional factor first. We'll be having multiplication by W20. This is 2.0, 2-point DFT, and W20 here. On this side we'll be having multiplication by W40 and W41. Fine. And this is the, this will be minus 1 here, minus 1 here. Similarly we'll be having minus 1 here and minus 1 here. So, and we have summations at these points, right? This and this. Okay, so x of 0 is 1, this is also 1, this is minus 1, and this is minus 1. So this is DIT algorithm. So the input will be in the bit reversed order, and the output will be in the normal order. So x of 0 is 1, x of 2 is minus 1, sorry, x of 1 is plus 1, x of 3 is minus 1. So we have 1 here, and there is a summation here. So 1 minus 1 is 0. Similarly we have 1 here, we have minus 1 here, multiplied by W20, which is again 1. So 1 minus 1 into 1 is 1. So we have 1 minus minus 1. So 1 minus minus 1 becomes plus. So it becomes 1 plus 1, that is 2. Similarly we will get 0 here, and we will get 2 here. Right? then we have a multiplication by dual factor. W40 is 1, W41 is minus j. So let's go to this summation first. So this is 0 into W40 is 0, so 0 plus 0 is 0, right? And then let's go to this point here, x of 1, so this is 2 plus W41 into 2, so 2 into, so this is basically W41 is minus j, so 2 into minus j is minus 2j, fine. So minus 2j plus 2, so it is 2 minus 2j, 2 minus 2j. Similarly here you have 0, fine, and then we have W40 multiplied by 0, again 0, so it will be 0. And the third last term is 2 here, and we have a minus 2j minus 1, that becomes plus 2j, so we have 2 plus 2j, 2 plus 2j, fine. So this is my final answer. So I can write my final answer as, so I can write x of k, I will get x of k as 0, then 2 minus 2j, fine, then again 0, then 2 plus 2j, fine. So this is my answer. Now let me go to another example. Now let's go to 8-point sequences. So here's an example. It says an 8-point sequence is given by x of n is equivalent to 2, 2, 2, 2, 1, 1, 1. Compute 8-point DFT using radix to decimation frequency algorithm. Right. So let me go to the next page now. For DIF, input is in this is in normal order, and output in reversed order, fine. So this means, so okay, I have drawn the basic butterfly diagram for decimation frequency. Decimation frequency FFT algorithm. As you can see, n equivalent to 8, so number of samples will be 8 from x of 0 to x of 7. So we'll be having basically 3 stages. The first stage we'll find 8 point, then we'll go to 4 point, and then finally 2 points. So it will be a reverse of DIT. Okay, so I have drawn the butterfly basic flow chart. So here the input will be x of 0 plus x of 4, so that is equivalent to x of 0 in our cases. So it is, I guess we have taken x of 0 is 2, x of 1 is 2, x of 3 is 2, x of 2 is 2, x of 3 is 2, and then finally we have all the inputs equivalent to 1. So first 4 inputs are 2, so I have 2 here, 2 here, 2 here, 2 here, then I have 1, 1, 1, 1. Fine. So we have a summation here, so it will be 2 plus 1, that is 3 here, and then here we'll be having again 2 plus 1, 3, again 2 plus 1 3 and again 2 plus 1 3. Fine. So we'll be having 4 3s. Then here we'll be having 2 minus 1 into W8 0. So 2 minus 1 is 1. 1 into W8 0 is again 1, because W8 0 is 1. So I'll be having 1 here. Fine. So then I have W8 1 here. Fine. W8 1 is, so first I will be having 2 minus 1, that is minus 1, into W8 1. W8 1 is 1 by under root 2 minus j 1 by under root 2. So W8 1 is to be multiplied by 2 minus 1, so that is 1. So I will be having 1 by under root 2 minus j 1 by under root 2 as answer. So next is W82. W82 is basically minus j. So I'll be having 2 minus 1, so minus j into 1, that's again minus j. So I'll be having minus j here. Fine. So then finally I have W8 3. W8 3 is again minus 1 by under root 2 minus j 1 by under root 2. So again 2 minus 1. So I'll be having the answer here as 1 into 1 by under root 2 minus j 1 by under root 2. Okay. So the after this is something which we'll do at your home, the second stage and the third stage. The final answer which we would be getting is, we'll be getting x of 0 as 12, x of 4 as 0, x of 2 as 0, x of 6 as 0, x of 1 as 1 minus j 2.414, 2.414, x of 5 as 1 plus j 0.414, x of 3 as 1 minus j 0.414, and finally x of 7 as 1 plus j 2.414. Fine. So this is what I will be getting, x of k. So what you guys will do at your homes is that so I'll write x of k. I will get x of k as x of 0. X of 0 is 12, and then I will get x of 1. X of 1 I got as 1 minus j 2.414, 1 minus j 2.414. X of 2 I got as 0. X of 3 I got as 1 minus j 0.414. X of 4 I got as 0. X of 5 I got as 1 plus j 0.414. X of 6 I again got as 0. X of 7 I got as 1 plus j 2.414. Fine. So we have 8 samples, 1 2 3 4 5 6 7 and 8. So what this is done using decimation and frequency FFT algorithm. You guys as a homework will do the same process using DIT FFT algo. This has to be done at home. Fine. So now let me come to the next example. Next example is find IDFT of a sequence x of k is equivalent to 4 comma 1 minus 2j. Fine. 1 minus what is it here? 1 minus 0.414j comma 0 comma 1 minus j 0.414 comma 0 comma 1 plus j 0.414 comma 0 comma 1 plus j 2.414 2.414 So basically on the capital N, this is using DIF algorithm, right? So we know, I guess in last lecture we had done finding the IDFT of sequence using FFT algorithm. Now, according to that, first step that we need to do here is we need to find the complex conjugate of x of k, that is x conjugate k, fine. So and then the second step will be finding 8 point DFT of x conjugate k, right, using dissemination in frequency, using dissemination frequency FFT, fine. So using that dissemination frequency FFT algorithm, we'll basically be getting 8x conjugate n, right? So then what we will do is that we will take the complex conjugate, we will take its complex conjugate to obtain 8x of n, and then finally we'll divide by 8 to obtain x of n. Fine. So let's go to the first step, that's finding the x conjugate k. Fine. So x conjugate k will be equivalent to, this will be equivalent to 4 comma 1, conjugate will be x complex conjugate will be plus here, so it will be 1 plus j 2.414, then again 0, then 1 plus j, minus will be converted into plus j 0.41401 plus into minus j 0.414 comma 0 comma 1 minus j 2.414. So first step is done, we have found out the complex conjugate of x of k. So now the second step is to find the 8 point DFT of x conjugate k using DIF FFT algorithm, right? So I will just draw the diagram. Or rather this diagram, finding out the x conjugate k, finding DFT of x conjugate k using decimation and frequency FFT algo is to be done by you guys at your home, and you have to mail me that. Done that. Fine. So basically, once I find out the DFT of x conjugate k, the sequence which I will be getting is x of k, that sequence will be eight comma 8 comma 8 comma 8 comma 0 comma 0 0 1 2 3 4 5 6. So 6 will be again 0 and x of 7 will be also 0. So we'll be getting 8 8 8 8. This will be equivalent to, as per my, so this will be equivalent to 8 x conjugate n. So 8 times x conjugate n, right? So there are no complex terms here, so it will be same as this complex conjugate. So I will basically getting 8 x of n will be equivalent to same 8 comma 8 comma 8 comma 8 comma 0 comma 0 comma 0 comma 0. So this implies x of n will be equivalent to divided by this frequency divided by this frequency divided by 8 points. So that is so this implies x of n will be equivalent to this frequency divided by 8. So this frequency 8 comma 8 comma 8 comma 8 comma 0 comma 0 comma 0 comma 0 whole divided by 8. So this will be equivalent to 1 comma 1 comma 1 comma 1 comma 0 0 comma 0. So this is my x of n, fine. So let me go to one more example before I finish it off. Write it here down. So it says compute IDFT of a square wave sequence x of k is equivalent to 12 comma 0 comma 0 comma 0 comma 4 comma 0 comma 0 comma 0. So 1 2 3 4 5 using DIF algo. Again, this example is to be done at so basically I will stop here. So at the end of this we have come to the end of chapter number 2. So in the next lecture we'll start with chapter number 3, that is filters. We have, I guess, IIR filters and FIR filters. So inshallah in next lecture we'll start with FIR and IR filters. Fine. So okay, take care.